Hi, I'm Steve Coffin from DME Brewing Solutions. I'm here at Upstreet Brewing today to talk about our Glycol utility connections. This is a typical DME Glycol utility diagram. For this example, we're looking at a 30-barrel unitank. You can see for this system, inside the brackets is the number of unitanks that are actually on the system. So in this case, there's 2. Below that, we can see that the maximum load is 14,500 BTUs per hour. In brackets is the required glycol flow rate we need going through the jackets to get the cooling we need. So in this case, it's 5.2 gallons per minute. So that maximum load is the peak load that the unitank is going to see at any time during the fermentation or crash period. Right below that, we see the average cycle load, which is 9,200 BTUs per hour. That average cycle load is used to actually size the glycol chiller and is balanced over the full cooling demand of the fermenter. Since all your fermenters won't be calling for cooling at the same time, that just balances the loads for a more accurate sizing of the glycol chiller. The vessel connections are indicated on the vessel approval drawings, so you can refer to your approval drawings to see what size connections are required there. All of the connection details are shown here along the side of the fermenter. Those details are sized by a mechanical contractor, but this gives a guideline for what is required to operate the DME equipment. So we have a supply header coming in. That supply header needs to be supplying glycol at 28 degrees Fahrenheit to the vessels and needs to supply the vessels at a pressure no higher than 30 psi. The first component off the supply header is an isolation valve. That's just a ball valve that will shut off flow to the rest of the components if anything needs to be handled for maintenance. Right after that, we've got the inline strainer, which will strain out any small particles that come through on the header and keep it from clogging up our automated valves or our jackets. Right after that, we've got our control valve. Now that can be a ball valve, a solenoid valve. There's many different options that'll be selected by your mechanical contractor. Following that, we have a pressure gauge. That's very important for troubleshooting any issues you may have with your cooling. And then we have individual isolation valves to each jacket. Now those isolation valves are used primarily if you're only doing part batches in the fermenter. If the fermenter is only half full, for example, you would use the isolation valves to turn off your top jacket. At the very bottom, we have drain valves, and that's primarily just for maintenance purposes. On the return side, we have a flow balancing valve. This is one optional configuration. There's a few different ways to do that, and your mechanical contractor can determine the best way that they want to balance the flow for your system based on your layout. And then we've got another isolation valve before we go to the return header. Now it's important that the return header returns to an atmospheric tank. Our jackets are designed only for 30 psi pressure, so we don't want to put too much back pressure on the system. Also, between the supply header and the return header, there should be some means to bypass flow in the event that there's very low cooling demand in the cellar area. That will keep a small amount of glycol going through the headers and keep those headers cold. So here we have the typical glycol connections on a fermentation vessel. This fermentation vessel has 3 cooling zones. We've got our cone zone, we've got our lower side jacket, and we've got our upper side jacket. So that upper side jacket can be turned off to isolate that top jacket whenever we're only partially filling our fermenter. And it's very important with a partially filled fermenter that we do turn that top jacket off, or we'll cause icing in the top of the tank. So with the glycol connections, we always come in the bottom and we come out the top. And that forces any air that's in the system, forces the air through and out that upper coupling and out the rest of the piping. In this particular install, they use George Fisher piping, which is one real nice way to install the piping. Not the only way, but it is a convenient means. Also, if we look up towards the top of this glycol system, we can see they have valves attached there, and those are for future expansion of the glycol piping. So that's one thing to keep in mind when you're initially laying out your piping, is what future expansion you may want throughout your cellar area. Thanks for watching. If you have any additional questions, feel free to contact your DME project manager.